talk is, clever, I like to think anyway, but it's Alexa, ask Cortana to tell Google to. But really what we're doing is talking about sort of cross-voice assistant development, specifically in .NET. So I have a few goals for you guys at least to sort of walk away with hopefully the ability to, and confidence to sort of go out and learn how to build more of these types of applications like Alexa skills, Google Actions, and all that, using your existing skills in whatever language really, although the samples we're talking about are in .NET. Is everyone here a .NET developer? Cool. Who is not a .NET developer? Is anyone here a JavaScript developer? Because that's going to be probably easier, honestly. Okay, cool. So I'll try to sort of scope it around like language agnostic stuff, but like the actual demo I'm going to do is going to be in .NET. But it's very simple. You'll get the gist of it. But anyway, so I'm Alex Dunn, like I said, but on the internet I'm not Alex Dunn because it's a very basic name and it's hard to find me if you look for Alex Dunn. So I go by Suave Pirate. Basically just built a little name generator when I was a kid and have sort of stuck with that ever since. And I'm a Microsoft MVP in .NET and AI, as well as a Pluralsight author, and have been working quite a bit in the sort of voice space, or the voice-first space as it's sort of known, but really it's the whole conversational AI space. And I'm the principal architect at Voicify, where basically we have a whole platform and a whole bunch of tools to do the stuff that we're going to talk about today at scale. This isn't a Voicify demo. This is very much just raw code, but just sort of my background for the last few years has been really focused on this space, building applications for all these different assistants, working on abstractions and tools to make it as easy as possible. So again, before I sort of really dive into it, there's a demo at the very end of this where I'm going to actually code for you guys and basically start with an existing ASP.NET application where you just have like an API and sort of show how we expose that data with all the great management stuff we already have as an Alexa skill in Google Action. I also have a bunch of blogs about this sort of series, both on mine and Voicify's blog. And I also have some docs in here just sort of get started with Alexa and Google Assistant specifically, although we are going to talk a little bit more about other assistants. They're just sort of the two most popular, at least in the US and the UK, to build for and for consumers to use. So basically, what is actually going on with all these virtual assistants? We see them popping up more and more sort of factors of use to, or more channels as well. So Amazon Alexa is obviously very popular, again, especially here in the UK as well as in the US. Really sort of started to blow up with the release of all the Echo devices, so smart speakers sort of became a new channel, a new piece of technology for people to communicate with, and both Amazon and Google were very much on top of that. Although Google Assistant existed before the sort of smart speakers we use today, both Amazon and Google build for both those types of platforms, as well as many others too, and we'll talk a little bit about that a little later. But there's also Cortana, a different approach to how they're sort of tackling the market, focusing mostly on the business side, on the enterprise side, enabling automation between tools and stuff like that. And there's also Bixby, which has sort of had a new come up. Anyone here a Samsung consumer, has like a Samsung phone or anything like that? Couple of you, yeah. So you probably disabled Bixby right away. Bixby has a whole new sort of rebuilt channel, and it's literally waking up on my phone right now. Let's not do that. Built mostly around developers and a new way to think about conversational design. But it all still falls within the same categories and the abstractions we're going to talk about today. There's also some honorable mentions for sort of like third-party virtual assistants. SoundHound has Houndify, which is a platform for building your own voice AIs, and same with Mycroft. So if you don't want to play with the sort of major players, you want to build your own virtual assistant, these platforms are sort of on the forefront of that from an indie perspective. So my goal, again, is to sort of break down the barriers of getting into the voice space, because from my experience when I got started as a .NET dev, there wasn't a whole lot there for me. There's a whole lot of no, there's a whole lot of like, hey, you need to be using AWS for this stuff. I didn't really know AWS a few years ago. Or if you're doing Google, you need to learn Firebase and GCP. So what I want to sort of go over is what those traditional development cycles are like and what the documentation pushes you towards before I kind of try to break it down a bit. So you can understand it and start to build on it without having to necessarily worry about the specifics of each platform or anything like that. So in Alexa development, it all starts with the Alexa Skills Kit. This is basically where we do all of our stuff in a development console. It's also where we worry about wiring it up to our code, which then is basically going to start sending a request to an AWS Lambda that we build in traditionally Node per their documentation, although they have SDKs for Java and Python as well, and then there are unofficial SDKs for some of the other platforms like .NET. But then there's sort of like a backend with DynamoDB, a whole bunch of libraries, again, that they built to sort of help that. And then we basically round out back to the Alexa Skills Kit, this sort of cycle that we manage. So this is sort of our stack, which is built traditionally in Node and on AWS. Google has a very similar setup. There's a little bit more of an in-between. So we start with Actions on Google. This is, again, a developer console. Google acquired Dialogflow, used to be API.ai or AI.api, I can never remember which order, which is now like the actual like natural language understanding portion and fulfillment portion for Actions on Google. So they're sort of moving everyone into using that as sort of the backend for it. But when you build on Dialogflow, you traditionally, again, push to a Firebase function. That's where your business logic lives. You execute it just as if you were executing a Lambda. That also helps support like Firebase databases and all the other sort of suites of tools in GCP built on Firebase. And then it all sort of rounds back out to getting the information back to Actions on Google, where we sort of keep that cycle going. So again, the traditional stack, again, is in Node, but instead of being on AWS, we're doing stuff on Firebase and GCP. Cortana is a little bit different. Again, like in the space they're playing in, but also in their tech stack. It starts with a Cortana skills kit, but it's not really the same. There isn't really a portal just for doing all your Cortana stuff. You actually create an Azure bot service, which exists as both the glue for your Cortana skill, as well as any other Azure bot that you want to build. And then that gets routed to your app service where your business logic lives. But instead of like going to the Cortana skills kit, managing a bunch of stuff, then your Azure bot service managing a bunch of stuff, they're kind of married a little bit more as a channel. So you're really just sitting in Azure the whole time, which if you're like me, it can find actually pretty nice. But then there's other things that you can do from there, interact with any other Azure services very easily once you're sort of in the ecosystem. But finally, we have one that's not built on Node, traditionally built on C#, but again, there are other libraries that we can use, and just like the other ones, they exist on Microsoft's cloud rather than Amazon's or Google's. Bixby, like I mentioned, is sort of new. I didn't even have a click-through for this, because basically you have an actual IDE for Bixby, its own proprietary programming language. You got to kind of learn. There's a little bit of Node that you can do to write your own business logic and glue, but really everything is pushed towards using this new programming model and programming language that's kind of functional, but also like data descriptive. It's funky. We can talk about that later if you want. I won't get into it today. So that's the traditional stack. If you go and try to get into the voice development, that's what you're going to find yourself doing. You're going to follow their examples. You're going to spin up a Lambda for Alexa, spin up a cloud-based function for Google, and go, neat. Now I need to actually like manage 2 clouds at once. And so what I want to start to do is break down the components that we have control over, get an understanding for how these things are actually built and how they run underneath, so that we can just build it in whatever tech stack we want, whatever tools we want, really. So it all sort of starts with what's called a conversation turn. There's a number of steps that are involved in this, but basically it all has to start with the user speaking. If you're chatting with a bot, because again, it doesn't have to be voice, the user has to say something. It'd be a little uncomfortable if Amazon just sort of popped up and started talking to me first. I'd probably unplug it myself, but it starts with someone else speaking to the device. That then actually runs through the assistance level stuff that we don't necessarily have control over. That's automatic speech recognition, where we take the speech that the person said, the audio file, turn it to text. Like I said, we don't really touch that very much in the proprietary sort of first-party voice assistant. If you're building your own, then you do have to do that. The second step is that the native assistant level goes through its process of natural language understanding. This is where we start to get control over it, and I'll dive into what we have to worry about, think about, and build in order for that to work. But then it uses our interaction model or language model that we built to actually execute the NLU, and then it sends a request to our endpoint. That might be our Lambda, it might be our Firebase function, or it might just be an endpoint that we've built. Then it's our job to basically process the request, do our business logic and all of that good stuff, and then return that whole response body back to the assistant, which then is going to either speak it out or display it, show some images, depending on what we do, what device they're on and all that, and then comes right back to a user having to respond. And if it's sort of the end, then that's the end of the turn, that's the end of the session, that's the end of the whole thing. The mic closes, everyone goes home. So again, we basically get to start control at that interaction model level, and then we get to worry mostly about our business logic from the request that's sent to us, and the response that we have to build from it. So from the interaction model, there's a few things we get to build and worry about and think about. But basically, it's a list of intents, which we just define, give it a title. We provide slots, which are like variables that we need to extract from what's said in order to do our logic. And then we have the sample utterances that match with it. So those are the things we get control over. There's other little things per platform that you can worry about, but sort of the gist of natural language understanding and building a language model is around defining these three things in various ways, however we want, and then running it against the actual systems training where they can actually worry about the complicated stuff. So we're just literally playing with strings and JSON files. The request body that gets sent to our endpoint, regardless of where it's hosted, gives us useful information that we can use to dictate our business logic. So that's session information, anything that we actually wanted to keep in session that's important to us, but also some information about the device. Does it have a screen? Is it like a smart screen like an Echo Show? Is it a phone? Is it a speaker? Is it a chat bot? And then all the actual NLU data. So when they said something, what was the intent that it hit when we ran through that processing? What variables did we have filled in and sent to us so that we can actually do something with it? And then when we build our response body after running through whatever business logic we want to tell the assistant something or have it speak something, we get control over stuff like SSML, which is speech synthesis markup language. It's basically an XML format where we can change the way that the audio sounds for certain words or use actual audio inlays alongside text and all that good stuff. We can also send images depending on the device and add custom session information that gets sent back up to us later. So when we're building out these language models, this is sort of that first step. There's a few things that we should start to think about. The first thing is, what is our app or skill or action going to do, or what does it need to understand? Then we need to know what we need to receive in order to do that action or give an answer to that question. And we need to know how someone's going to interact with it. So when we're building that language model out, we can start to answer these questions with the technical terms. It's a little different per platform, but I'm sort of going to give what the sort of industry standard is and some of the other synonyms for it as well. So for what our skill can understand and do, that's where we define our intents. So that's really what the intents are to us. They might be called actions. They might be called an interaction type. What we need to actually do that action or answer that question are the slot values. We don't necessarily need the full text of what someone said. We just care about the values that are sent to us as slots or variables or parameters. And then how users actually interact with it, how do they execute that intent? Those are utterances or sample utterances or just samples or phrases, sort of the various different ways that we talk about it. So I'll give you an example of a custom intent. So this is similar to what we're going to actually be doing in the demo. If we're going to build an application where we can give a fact about an animal, right? So what can it do? It can give us a fact that of the animal that the user asks for. So the only thing we really need is the name. We don't really care about the way they said it. We just need to know what is the animal so I can look it up and give you the fact. And the way that someone says it is maybe tell me, a dog fact. So to sort of break down that, tell me a dog fact, basically the dog is that slot value that we care about. The whole thing is the phrase, and both of those sort of combine into the actual intent that we're defining them under. So once we've sort of defined that phrase, those intents, whatever we want to start to build or support, this is where we get to worry about our code to actually execute the business logic. Sometimes it's called an endpoint. Sometimes it's specifically a fulfillment endpoint or just called your fulfillment. So those can be serverless functions like Lambda or Firebase functions or the old school GCP functions or even Azure functions with a gateway in front of it. But it can also just be any stateless RESTful web API. Basically, all we have to worry about is the structure of the JSON that gets sent to us and what we send back down. And the easiest way to abstract that is to start by using a stateless web API rather than hosting a Lambda function and hosting a Firebase function or anything like that. Come on. So the stuff that we get sent to us is the actual intent, right? So that's the first thing we need to start running that code to figure out our business logic. We get the slots if there are any. You can also just have intents that don't have slots. It's just the phrases. For example, the traditional help intent, if I just say help or what can I say or something like that, there's no values I need out of that. I just need to know that the user needs help. We get session info, like I said before, the conversation state, and device capabilities traditionally. Some assistants don't provide as many details of the device. They might just say, yeah, this one can use video and this one's just a speaker, where some of them go into depth about like, hey, this is a screen and here's the aspect ratio and the pixel density. And all of this information gets sent up in every single request. Every single one of those full conversation turns, we get all this detail. And also a couple other things depending on the platform. So what we can do with that information is basically start by figuring out the intent and then running the unique business logic that we need. That could be a switch intent. There's other ways to handle this abstraction, which we can get into later. Then within that, we need to run our business logic. So for example, if we're now in the animal fact intent section of the business logic, we're going to extract the name of the animal from it. We're going to actually look up the animal fact. In this case, we're going to use Entity Framework. So I'm just grabbing a reference to my database context. And basically pulling out the single animal by the name. And then if we have one, we build a response. And we can use tools for that, SDKs that make it a little bit easier so we don't have to build this giant model in our C# code. So in this case, I'm using Tim Hewer's Alexa.net SDK for this specific example and just saying, tell them the fact, which is just going to return the audio. If you're on a screen-based device, we're not doing images or anything like that. It'll just be audio-based. So the details of what we send back is text in SS or SSML. Doesn't necessarily have to have a whole bunch of stuff, but it can be as complicated as you want it to be. That starts with just saying something like that, responsebuilder.tell, but we also have the ability to return quite a bit of information depending on the device and what we're trying to support. So that could be text that's different than what's spoken. Maybe they're sort of talking about this multimodality. They want to read something that's shorter while hearing a longer audio, or vice versa, depending on the context. We can return audio files. Maybe the question they asked is to play a certain song. We're not going to return an audio response. We actually want to return the audio file itself to start playing. Same thing with videos, images, and also any updates to the conversation state. So that's the basics. Does anyone have any questions around sort of I guess it's like the fundamental or foundations before we get into the slightly more complicated stuff? Cool. Hope everyone's tracking. So I want to sort of take one more step further up, talk about now we understand that we have to build a language model for each platform, and we write very simple code. We can just host it as a web API. We get JSON. We send JSON back, nice and simple. But there's some other components to the sort of voice space or the conversational space that's different. It's not just building an API that consumes stuff. Our business logic isn't always just look up this thing and send it back. There's a few other things we have to worry about, especially when building and designing very complex and conversational applications to help a user get to what they really need or to do the thing that they're really trying to do. So the three things are MultiTurn Conversations, and basically that idea is that we have the ability for a stateless API to handle a turn, but how do we handle the many different turns that can happen? Multimodality, the idea of supporting many different devices that are out there. I've already named a few, like smart speakers, phones, screens, TVs, whatever. And contextual conversations, which means providing the right response at the right time for the right user. It's not always the same thing. It's not sort of a blanket statement for the best type of conversation design. So MultiTurn Conversations, if you remember, this is our cycle for a single conversation turn. User speaks, we process it, sends it to our endpoint, we build our response, send it back. Basically, all of MultiTurn as a foundational point is that this happens over and over again. That's the basics of it. There's many different ways to handle it, sort of like workflow-based MultiTurn, where they need to go down certain parts of my decision tree, or maybe it's just open-ended and I don't care what they're doing, just keep the conversation going, I want to keep them busy. Modality in conversations is interesting, and this becomes a bigger challenge as sort of the years go on. We see so many different devices added into this sort of voice-first ecosystem. It started with phones and smart speakers. That's all we had to worry about. We didn't even have the ability to send images back down like 3 years ago. All we had was speakers. But now we have to worry about things like our actual PCs. If I'm using Cortana on my PC versus Alexa on a speaker versus Assistant on my phone. We have to worry about cars. We have to worry about smart screens of many different varieties from different providers. The Facebook Portal versus the Echo Show, even though they're both running Amazon, they function a little bit differently. Watches, wearables, just right into our headphones. And that's important because when we're building contextual conversations, we need to think about the very fine details of those devices and the modality that we should be providing. So modality isn't just like what the device type is, It's the many different ways that we communicate. A mode of communication is audio, just speaking it, but also reading, seeing, hearing speech and other sounds at the same time. Ways of communicating and getting the detail across, and doing many at once, depending on the device target, can be challenging to do right without either boring the user with like Alexa's voice droning on, or overwhelming them with a whole bunch of information at once and then being like, now I need you to respond right now. We have to think about those things when we build and design our applications. So contextual conversations is basically lifting a lot of that detail out into building good conversational apps. So context matters on input in terms of what we get. Where is the user at, like, geographically? Are they in a space where I can use their baked-in language of their device, or is it something where there's even like a blend of languages, or is it somewhere like I know they're on a street versus in a building? Those kinds of details matter for our business logic. What did they say last time? Again, we're building stateless APIs and functions. We don't just have like a whole storage of what everyone has said ever, but it does actually matter to know what the user said last time. At what point in the conversation are they, and what do I need to do based off of that sort of current state? Also, what information do we have on the user? Do we have their email, their phone number? Do we have very fine details about their location versus like the general zip code or something like that? Was the response that they gave us in this sort of prompt what we were expecting back? Or is this something that they just sort of threw out there and now we got to kind of handle that? And also, did they provide everything that we need to actually get them to the next step? It's not as simple as just taking a phrase and running through it. Maybe we need more detail to help them get to the next step and then use that on the output. So again, context matters on the output, and some of the same contextual things matter too. So where is the user? If I'm in a car and I'm driving and talking to like my Alexa Auto, or I have headphones in, like some crazy person that doesn't want to listen to their surroundings, it happens. Understanding that I'm driving and I need to provide a response to the user that's not going to distract them from the road too much. Maybe it's like, I don't need to provide a video response if they're using it on a screen because I don't want them turning their head away from the road. But if they're just on a smart screen that's right in front of them in the kitchen and they ask for a recipe, I need to give them all the detail they can. That matters in the actual output that we build. What device type are they on? That's sort of the modality part of the question. Do we need anything else from them to carry on? So are we just prompting them for something else? Is it more open-ended, like, okay, you did it, like, what else can I help you with? Did they say what we wanted in the first place? Are we just going to like re-question them? Should we question them in a different way to get the response we were expecting? And how do they expect us to communicate? This is sort of the hardest problem in the contextual conversation side of things. And it comes down to actually user testing, which I'm not going to get into today. But basically, the idea of context and contextual conversations is that it's the implementation of a multi-turn conversation based off of the details we have on the user and on the modality that they're coming from. Those are important things to build to and to think about when we're designing and actually implementing our business logic too. So, any questions now? Otherwise, I'm going to sort of step into demo mode here for a little bit, and we'll take a look at an actual application and get started building out some of the basics. Cool. So I'm going to focus mostly on Alexa and Google. If we have time, I can get into Cortana and Bixby as well, or even just some like chatbot stuff. But basically, we're going to go through the steps of building out an application based off of what we already have. So we have an existing API. And we're kind of like voice enabling it to give us animal facts. Skipping over that sort of next level stuff of modality and all that because we don't have time to get into how to build that business logic out. There's a number of ways to do it. But let's start with Alexa. I'm going to go into the Alexa developer console in a little bit and show you, but basically, I want to show you the steps we're going to go through in building out the language model and then also the code as well. So it's going to start with us building an intent. We defined it here. We fill out the values with the slots in there as variables. We define the value and the type of our slot, so it's an animal. Luckily, Amazon gave us a pre-built type for animals, so we don't have to like define that with every animal on Earth. We can also extend the built-in one here with some extra stuff if we want to. And then we wire it up to our actual endpoint. This is where we tell Amazon, hey, when you actually get a request for my skill, send it to this URL. If you were doing it on Lambda, it's the opposite. You basically just give it the skill ID for your Lambda or your Lambda resource number and basically tie them together so it knows to send it. It's sort of internal. And there's resources on both the stuff I'm going to be building here as a blog post, but also specifically the SDK. Amazon doesn't have an official SDK for .NET, Not sure why, but they still don't. So we're using Tim Hewers. This is sort of the go-to for the community in the .NET world building Alexa skills. And it's really easy to use. It sort of follows the standards of the Node one and the Python one from Amazon, but it's in C#. For the Google Assistant side of things, we're going to be using Dialogflow for defining our language model, but same sort of thing. You can start to already see how similar the setup is. I give it an intent name. I define some utterances with some samples. I highlight the things that are variables and fill them out. I can define the slot below that with my animal type and give it the type of animal, where I can also extend it and add different things and synonyms and all that good stuff. And again, just wire it up to say, send your stuff to my endpoint here. And alternatively, you can do it as a Firebase function, which you can either edit right in Dialogflow, or you can host it anywhere else and just sort of point to it. Same thing here. There is a Dialogflow SDK. John Skeeta actually built it, but it's generated, and it doesn't have the models for Google Assistant, which basically Dialogflow is built side by side with it for just the NLU side, and they just use like a straight object for what is the actual Google Assistant package. So in the demo, I basically just built my own models for it. But if you want to take a look at the actual package, it's there. And again, I also have blog posts on this as well that go into sort of details of patterns and the weird nuances of the platforms as well. Cortana, which I'm not going to actually do the demo for today unless we have time, but still a little bit separated, similar to Google and Dialogflow. It's not all in one place. We actually use Lewis, which is now finally getting fully rolled into Azure. It was a sort of side-loaded thing before because, again, they also acquired Lewis. Same thing, though. We just give it an intent and give it some phrases and give it the type. We can define the type. We can give it samples of the actual type itself and the role that it fits. And then we basically define our bot channel registration. Again, you can sort of see that endpoint here where we're going to tell the Azure Bot Service to send the request to. It's already an Azure App Service, so it's pretty easy. And then you can do some stuff to wire it up to your Lewis app, or basically hit the Lewis SDK from your business logic. Either of those is fine. Bixby is a little bit different. Like I said, this is the proprietary Bixby language. It's both modeling and coding at once, which is an interesting take, but same sort of thing here. We define an intent, give it a description, but we don't define like the sample utterances here. We do define the input parameter, that slot of our animal name, but we actually have to like give everything a type. We can't just say animal name's a string, give me whatever fits there. Instead, we define animal name as an object, and it's just a name of something. And then we define our utterances separately. We put all of our utterances for all of our intents or actions in one place, and basically they have a whole bunch of stuff that kind of like, I forget their official name for it, but it almost like builds business logic for you on the fly based on your model, which is cool. But then we also add an endpoint in a separate area where we define it here, and we say we want you to post it to us, and this is the endpoint for the animal fact intent if you give it an animal, because you can use local endpoints that just run your Node code, your JavaScript code, like right in Bixby Studio, or you can have it run remote, which is what we do here. And so, yeah, let's get into it. Let me see if I can easily switch this to extend. Cool. Come on, catch up. Oh wait, no, I want duplicate, not extend. Hold on. Cool. Is that tracking? Awesome. Awesome. So, like I said, we're starting with an existing app. This is just a RESTful API. I'll sort of start by going through the structure of it, and then we'll sort of build on top of it by getting our Alexa skill, seeing how it actually sounds in the end, and everything else. So to start, I'll open up the Solution Explorer here. This is as simple as it gets. I actually like generated controllers based off context. Not recommended, but I did it. So we have a model here for our entities as an animal fact. Basically, we get an ID, an animal name, and a fact. The animal name, we can create as many as we want. We're not necessarily going to search direct. We can do like a contained search or something like that. But the idea is that this is the type of data we're managing. Like I said, I'm using Entity Framework, so we have our animal context, which has our DB set of those animal facts. And if we look at our controller that's generated, we have the sort of management stuff we'd expect. So I can If I scroll down, I've injected my animal context in here. I can get all of the animal facts that I have. I can get a specific one by ID. I can update an existing animal fact if I want to make any changes. I can create a new animal fact. I can delete them as well. And basically, this is the generated stuff if you've ever used, like, give me a controller using Entity Framework. So I can't even take full credit for this. So I've also added Swagger in front of this using Swashbuckle. So why don't I actually start by running this? And of course, it can't connect. Let's try running it from the application and use Kestrel instead. Cool, so we're running at 501 here. Like I said, these are all the endpoints from that controller. Swashbuckle is automatically generating these for me, but we can actually try these out. Has everyone here used Swashbuckle before for your APIs? Has anyone not, and you're like, oh my God, how did you get this ability? I'll show you in the startup how it's all wired up. But basically, we can actually start hitting the API here. So this is hitting the one to get me all of my animal facts. And basically, we have dog is super cute. Cats make Alex itchy, and we have a fact about leopards. Did you know they can jump over 35 feet? Some fun facts. We can make edits to these if we want. I won't bore you by showing you every single endpoint. Kind of get the gist. So let's start by taking a look at the Alexa skill side and actually getting stuff wired up. I've already deployed this to Azure, so we're not going to have to sit around and wait for me to right-click deploy like a monster or wait for any sort of CD to run. So just so you know, it's here at animalfactsvoice.azurewebsites.net. Same thing exists, same exact endpoints. Let me actually do this, show you the animal facts that we can use from the remote one so you can believe me when I get the actual live data from the response. Come on, internet. So like I said, this is hosted in Azure. I'll just let that sort of wake up because it's running on a free server. It's just an Azure app service that's running the very basics. I'm running in a free plan, so I don't have to pay to run my demos. We can keep an eye on our monitors and stuff like that. And that's what we're going to hit here if it ever wants to wake up. If not, we can hop over to the Alexa side. So if you remember the sort of flow from earlier on how we actually build and manage Alexa skills, it starts with the Alexa Skills Kit, and all of that is managed within the Alexa Developer Console. It's the same place if you've ever deployed an Android app to the Amazon App Store for Kindle or the Fire phones when those were a thing. Same place, it's just sort of a subdomain, so it's in the Amazon Developer Portal. But what we can do is actually go into our skills, and I'll show you what the actual creation process looks like as well, because it's very straightforward. It's just a couple click paths. And again, I think my internet is just giving me grief here. Oh, that's why. Sick. Cool. So we can create a skill. We could call it like NDC animal facts. Choose a model. For Alexa, there's actually a bunch of different ways to build skills. What we're talking about are custom ones, but for example, you can build flash briefings, which is what happens if you just use your Alexa and say, like, what's in the news. Flash briefing skills you added are built that way. You actually don't write very much code at all. You kind of just give it an RSS feed and it works. Smart home, music, video, baby activity, oddly specific. These are very focused on sort of a reason and a way to interact with them versus the custom ones where we have a little bit of flexibility, but we can't basically breach into these other types from our custom skill. So the ability for me to tell my Alexa device to turn the lights on in the living room, that happens specifically from a smart home skill. For using custom skills, they're more like traditional apps where we actually open it and start to have a conversation with it. That's basically what I've built for this Animal Facts app. So this Animal Facts demo we have here, I have the built-in intents. The only one that's been added is this animal fact intent, where I've defined the slot type animal, which you can see is embedded in this intent. You can use slot types across other intents. So if I wanted a different way to ask about an animal that's not like give me an animal fact, it's a little more specific, I can create other intents and use the same slot type across them. But it's just showing you that it's being used here. And so I give a couple utterances, just the name of the animal in this case, or animal fact, or give me an animal fact. And if I click on the animal one here, we can see that it has the slot type animal, but I can also extend it. Whenever I make changes to my interaction model by either adding an intent or adding an utterance, I have to both save it and then build it. It can be a pretty long process to build an interaction model, which is why I've actually gone ahead and built this out, saving us like 5 minutes of watching loaders. But that's sort of the gist of how we design our language model in Alexa. We just write intents, we write utterances, and give them slot types. And then down at the endpoint section, we then define our endpoint here. So this is, again, hitting that animal facts Azure websites, specifically the API assistant and then the Alexa endpoint. But if we switch to a Lambda, we would just hit this button and choose to point at our Lambda there instead. So let's see if this actually worked for me. Cool. OK, so now this is the actual animal facts Azure website. So this is the real data we're going to be able to play with. I have a nice Halloween one here from when I did this during Halloween, but I think the most important one here is the dog, where I can give the fact of, did you know dogs do in fact have a sense of time, and they even miss you when you're gone, which is the saddest fact ever as a dog owner. So let's go ahead and actually add the Alexa fulfillment side of things to our local code here. Basically, what I need to do is create a new controller where I can start to consume the requests that Alexa is going to send to me. And I'm going to use all the models from the SDK, so I don't have to rebuild everything from the JSON. But when I'll set it up with Swagger, so you can actually see the full size of the object that gets sent to you and all the details that it can capture. So let's start by adding a new controller in here. And in this case, I'm going to actually just start with a base class, but assistant controller. I'm going to put all of the different assistance logic in one file just so I can scroll without swapping files on you guys, but sort of a general separation thing. I wouldn't normally do this by having just an all assistance controller. And then I'm going to inherit an API controller. Bless you. Oops, not API controller, just controller. Controller, please. OK, we'll give it the route. Matching the one that we had before, which is API/the controller name, in this case assistant. The next thing I need is to also inject my database context like I did in the base animal facts controller. So I'll just start initializing that here. Private animal context. And we'll just call it context. My favorite shortcut so far with doing a lot of dependency injection, for those of you who haven't seen this before, or maybe I'm just nuts and you all know this, highlight it, control period, generate constructor with that. Oh my God, so easy, instead of typing them all in the constructor parameters. Cool, so like I said, let's start with Alexa. So I'm gonna give it just an HTTP post. Everything goes over post on the Alexa side of things, and I'll just call this Alexa. And we're gonna do a async task of iAction results. And we'll just call this handle Alexa. So basically, we get a bunch of stuff sent to us. There's some headers that you traditionally have to use to actually check the certification. One of the things that's interesting, if you do an API, a RESTful API endpoint rather than Lambda, Alexa, before you publish your skill, requires you to automatically validate that it is your skill that's hitting your endpoint. So that they're doing it to protect you as well as themselves from someone mimicking Alexa on the fly. I'm not going to do it in this case because they don't do it in the middle of development, but when you publish it, just something to know, you have to do a whole bunch of certificate checks against what's sent in the header, against a specific endpoint. Content on how to do that in .NET's out there. But basically, we're going to start by getting a skill request sent to us. And we'll just call this request. Also, is this big enough for everyone to see? Anyone in the back having issues? Cool. Awesome. So like I sort of broke down earlier in the logic that we have to worry about, the first thing we need to do is consume the type of intent or the type of request we get to start to segment the business logic before we build a response. In Alexa, the sort of launching of your app by saying open animal facts isn't actually an intent, it's a different type of request. And so what I can do in this case is actually say, if the request.getRequest type is the type of launch request, which means I probably need another namespace, then we can run some business logic here to welcome the user to the skill, give them an idea of what they can do, introduce them to the types of things they can say, maybe give them a sample or whatever. So in this case, I'm going to actually return an OK response because I expect an action result. And in this case, I'm going to say response builder. This is another tool brought to us from Tim Hewer in the SDK. And I can just say ask. Basically, the difference between ask and tell is ask will leave the mic open and the session open if you just tell it sort of the end of it and the mic closes. So in this case, I want to ask the user something, even though I'm kind of making a statement. But I can say, welcome to Animal Facts. Ask me about an animal. From here, we can do a number of other things from the .ask. I'm not going to return a reprompt. For example, we can update the response here that's given to us and add like our images, our session attributes, or anything like that. But in this case, I'm just going to stick with sort of the basics of just asking. Let me put this on a new line so we can see it. Cool. So we can handle when someone opens the app, and now let's worry about that actual animal fact intent. So we get a different request type if we're getting an intent, appropriately named intent request. So I'm going to just sort of separate this a little bit more to intent request. So now we can guarantee that we have an intent, and that means we're going to have other properties available to us. So we can cast the actual request's inner body. So I can say like var intent request equals the request dot request classic as intent request. So now we can actually start to access things like the intent name, the slot values, and stuff like that. So in this business logic sort of segment, we need to make sure we're getting the animal fact intent. And then from there, we need to take the animal's name and actually go check against Entity Framework for the content there. So I'm going to do another sort of break here. Again, this could be a switch statement. We could use a handler registration pattern or something like that. In this case, I'm doing it all in the controller because this is demo code. Please don't actually judge me. I don't do this in real life. So we can say if the intent request dot intent dot name is animal fact intent, because that's exactly what we named it in the Alexa developer console. Then I want to get the animal name from the actual request. Animal name equals intent request dot intent. Let's see if I can remember this exactly. And we called that animal in all of the sample utterances. So now we have the animal name because we know the structure of our request and that you have to have an animal when you're using the animal fact intent. We don't really have to do any null checks here, although I probably should. But now that we have the animal name, we can just do a very basic lookup against our DB context. So I'm going to say animal fact equals await context dot animal facts, and I'll just sloppily use first or default async. So if we have, let me break this out again. If a dot animal name, we'll to lower it, equals the animal name that's sent to us, not to lower. Oh, I need to cast this as a string. Oop. Oh, sorry, dot value. Animal name dot to lower. So now we need to actually separate how we're going to build our response. Maybe they asked about an animal that we actually don't know about. In the case of previously, we had a fact for a dog as well as a cat, and also just some test ones in there. But let's say they actually asked about like an elephant or something like that. We need to know if basically animal fact is null. Well, fact is null. Then we're going to want to return a response to let them know that we didn't find anything for that and that maybe they should try a different animal. If we know the ones that we can support, we can be very clear about the types of things they can say. But once again, I can just return OK from here and use that response builder again. And in this case, I'll ask and I'll say, I don't, can even get really specific here. I don't have a fact for animal name. Try a different one. But if it's not null, we can confidently return our response with the animal fact. So I'll do the same thing. Response builder, oops, not that, dot tell. And we'll just give animal fact dot fact. And I keep forgetting I need a null reprompt on this one so it doesn't keep yelling at me. And finally, basically, if we received a request that we didn't want, we don't want to return like a bad request or a not found or something like that. We always want to return OK, because otherwise the assistant's going to actually consider it a crash and actually crash your skill, kick the user out, and stuff like that. So if it's not a launch request and it's not an intent request, then basically we can return another OK. But in this case, I'll just give sort of a generic, like, I didn't understand that. Try something else. Cool, no more errors. So let's go see what this actually looks like in testing. We can test this on a real device. When we go to the Alexa developer console, we can switch to test and turn on testing for our skill before we even publish it, which enables us to use the simulator here, which I'll do for the sake of this demo. Let me get my volume up as well. But if you have an actual Amazon device registered to the same account that you're signed into here for your developer account, all of those devices can now actually use your skill. Which is pretty cool. So if you have a sort of house full of different devices, or maybe you have an office full like I do, all you have to do is basically flip on testing, and you can immediately start to test it on these different types. The actual simulator here does give us a lot of information, including the JSON that gets sent up and what we sent down, as well as the ability to simulate different device types. So we can simulate screens of the different varieties that Amazon has officially shipped, and we can even define custom ones. So if you're building something for like Facebook Portal, which is like a vertical version, sort of like a portrait mode, you can add a custom device, like register your sizes and dimensions and all that. But to open the app, we just say, open animal facts demo. That's the invocation name we gave it, and hopefully the internet will be friendly with me. I don't hear anything either.
Welcome to the Animal Facts voice app. You can ask me about all kinds of animals. Try saying, tell me about dogs.
So I won't say exactly that, but I'll say, give me a dog fact.
Did you know dogs do in fact have a sense of time, and even miss you when you're gone?
It's even sadder hearing someone else say it. Okay, so just to prove this is coming from the same API, what I'm going to do is hop over here, grab the ID of dog, and I'm going to go change the fact a little bit. Let me actually just grab the whole thing. So the ID is 4. I'm going to come in and update it with 4. Slap that in here, and I'll just change this to say like, hey, NDC, and then still give you the sad fact. Cool. So back here, I'll exit and refresh the sort of session we're in. I have an extension here which lets me just like click to repeat a previous phrase, but normally you actually have to type this all out.
Welcome to the Animal Facts voice app. You can ask me about all kinds of animals. Try saying, tell me about dogs.
So I'll say again, give me a dog fact.
Hey NDC, did you know dogs do in fact have a sense of time, and even miss you when you're gone?
Excited and sad. Okay. Cool, so Alexa is covered for this very simple example. Let's switch over to the dialog flow side of things and the Google side of things. So basically I have these two different tabs open here, the Google Actions console and the dialog flow console, because I need both. So the Google Actions console is where I sort of build my action, develop it. It's where I give it the invocation name like Animal Facts Demo. And you can even see here, this is where I register the action to actually go to dialog flow. And then from there on, dialog flow basically takes over all of the NLU for me. But the same thing is also available to us here as a test simulator. The same rule also applies if I'm signed into a Google account that also has all of my different devices registered. I can immediately test on these as well once I turn on testing. But before we do that, let's take a look at the dialog flow side at the intents that we have. So for dialog flow, welcome is an intent, so we don't have to do that extra request check stuff. But we also have our animal fact intent. It's going to look very similar to what we saw on the Alexa side. I just defined some phrases. I gave it a name. I added some samples here for dog, and you can even see that's mapped down here to the animal type. We're pulling out the value animal, all the same sort of parameters, and I even gave it the same exact name of animal fact intent. So on the code side, we have to register the fulfillment, just like we did on the Alexa bit. Come down to the fulfillment side. I put in the same URL here and enabled it. Like I sort of showed quickly in one of those screenshots, we can also just use an inline editor to add a Firebase function. Alexa also added something recently like that in this code tab where you can actually edit Lambda code if that's your preference. Both are only available in Node, but obviously it's not here because I deployed with my endpoint rather than using that, so it's just going to tell me, check back later. So the last thing we need to do on the Dialogflow side is we can actually choose to reply directly within Dialogflow without even sending a request up. It's not like Alexa where everything has to go to my endpoint. In this case, I can actually choose per intent which one does, but because I want all of it to go to mine, I basically have to scroll all the way down to the bottom to this fulfillment section and say enable webhook call for this intent. So let's quickly add this to our sample. So I'm just going to add another endpoint here. We had the Alexa endpoint. I'll collapse that. And now we're going to want to add a Google Assistant endpoint. Google Assistant. I'm going to follow the exact same setup. There is one actual sort of quirky thing with the .NET serializer that I do have to worry about with this response, and I'll explain it in a little bit. But basically, just like handling the skill request, we're going to take the request body. This time I think it's an action request. Yes. Call that request as well. So real quick before I just sort of finish typing this out, or I might even paste it just to give us some extra time. There's an issue in Dialogflow with receiving fulfillment from .NET in JSON structure. I've talked to John about it because he's the one that wrote it and is familiar with the issue, but basically the .NET default serializer of JSON, even if you're using Newtonsoft or the newer stuff with ASP.NET Core 3, Google just has like a weird time recognizing it, and it like thinks the whole thing is just a string instead of the actual JSON structure. There's basically like some weird Unicode issue between the two. So to be explicit, we can't just use the OK result. We actually have to use the JSON shortcut or a JSON result instead. So instead of using an iAction result, I'm going to be explicit just to help myself out and say that I need a JSON result here. So this can handle if it's an OK response or not. I just have to be sort of explicit about it. Like I said, for the sake of time, I'm going to grab this from the existing one and then just sort of step through it with you all. Let me take this. Cool, 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 cool. Yeah, I definitely just copied that new line only. I did. I'm an idiot. Let's take it over here. OK, so very similar setup, except we're returning JSON. I'm going to need to pull in all of these. I want to call this request instead because I changed it. So if we wanted this to be, for example, the welcome intent, we're going to want to provide the same response like we did on the Alexa side, where we say, welcome to Animal Facts, ask me something. So basically, we build the same type of business logic. We need to grab values from different parts of the object because it's a bit different. So instead of having to do any of this weird casting and stuff, I can just say, give me the query results action. That's sort of the name of the intent as a string. So then I can start to worry about these switches in here. Similarly, I don't have to do any casting to get a slot. I can instead go right back to that query results option because it's always there in every request type and pull out the parameters. Same thing, we're going to grab the exact same name. Then we're doing the same exact business logic. This could obviously be extracted a little bit more, built a little bit cleaner. But in this case, we again grab the animal facts and grab the first one by its name. And then if we have null, we want to return the dialog builder ask. I built my own little shortcuts here just to build out the text. But then if we do have the fact, we want to return the fact just as a response. So we can, again, go over to the simulator for Google. They give us nice little suggestion chips automatically, so I can just click this to get started.
Getting the test version of Animal Facts demo.
Welcome to the Animal Facts voice app. You can ask me about all kinds of animals. Try saying, tell me about dogs.
So I'm going to again say, give me a dog fact.
Hey NDC, did you know dogs do in fact have a sense of time? And even miss you when you're gone?
And then it left me, just like I left my dogs at home. Cool. So that's Alexa and Google. I want to sort of give you guys a chance to ask questions. I didn't want to build out this demo too complicated. There's some more details in the GitHub where I can show you how to do like cards and SSML and all that cool stuff. But yeah, any questions or anything? If not, I have I got to sort of plug PubConf for you guys. No? Cool. Okay, so that's all I got to do for today. you can always come up and ask me questions later, but I'll also be at PubConf tomorrow night. If you aren't already signed up, it's like the most fun thing ever. Basically, a whole bunch of satirical, comedy-based, but like developer-focused talks while everyone's just drinking and having a good time at an actual pub. So it'll be 7 p.m. tomorrow at the Barley Mao? I don't know how you guys say it out here. I know there's a number of them, but the details are at pubconf.io. And yeah, thank you for coming to my talk at the very end of the day. Also, at the end of the party, I'll be performing with Dylan in the Line Breakers, so come catch me on guitar. Cool, thanks everyone.